geometry, we are wrapping up our week with CO29. And in the past two objectives, we talked about two different centers of a triangle. Okay? We had the circumcenter and the incenter. Who can tell me how each of those were defined as the center of a triangle? Aiden.
The circumcenter is the same distance from each of the angles of the triangle.
Right. So the circumcenter is the center in the sense that it's equidistant from the three angles. The incenter, Kylie?
It's equidistant from the sides of the triangle.
Yep, it's the middle, and that is equidistant from the sides, right? The third one is called the centroid. Okay? Whoever named these things just did an awesome job. Centroid. Okay? And the centroid, folks, the centroid is formed by the, point of concurrency of the medians. And a median is a segment that connects a vertex to the midpoint of the opposite side. Okay? A segment that connects a vertex to the midpoint of the opposite side. So, for example, we've got a triangle right here. Okay, whoops. The median, and there are three of them, right? So you have three vertices inside of a triangle. The median would start at the midpoint and go to the vertex, right? That would be a median. And it looks like sometimes it bisects the angle that comes from. It does not. That would be an angle bisector, okay? This one bisects the opposite side. All right, so those two pieces would be congruent. Yes?
So, it's not an angle bisector because the angles it makes might not be.
Correct. It's not an angle bisector. How it bisects the angle will depend based on how big the angle is and what type of triangle it is. If you look down here a little bit further, down at point Y, it's pretty clear to see that median does not bisect angle Y there. Okay. So what they do is they do come from the midpoint of the opposite side. Right. So we have a mid segment which connects the midpoint of two sides. We have the perpendicular bisector, right, which bisects a side at a 90-degree angle, whereas this doesn't necessarily. We have the angle bisector, which bisects the angle. And now we have medians that go from an angle to the midpoint of the opposite side. Okay, kind of four different characteristics, four different qualities that triangles have. And each one kind of serves its own purpose. Yeah, Tyler.
Isn't median also used for the averages?
Yeah, so median is also one of those average words, mean, median, mode. I don't know why they picked median for this. It takes the average of the opposite side per se, but an angle bisector takes the average of the, so I don't know. They're not really that related. Okay? But the centroid is the point of concurrency of three medians. Right? The point of concurrency for three medians. Of course, that point of concurrency means where they intersect. And we're going to draw an example of that down below. I'm going to move my page down low before we do it, so get these notes, and then we'll draw some medians. Yeah. All right, you ready? There you go. So theorem 5.8, concurrency of medians of a triangle. I want to make my triangle kind of very much not equilateral. So you can definitely see all this stuff happening here. Okay. So if you want to make a triangle similar to mine, it looks kind of like the triangle I have down below, which might be helpful for when you go to work on that there. Okay. But drawing in the three medians, we'll start with the most difficult one probably because it's the furthest that you have to draw it. Mark the midpoint. We'll put sides on here. Mark the midpoint of AB. Okay, and it's going to be an approximation, but eyeball that one. And then draw your median from angle C so that it connects with that point. And we'll call this point X. So here you can very clearly see it's not an angle bisector. It does not bisect angle C there. And it doesn't intersect segment AB at a 90-degree angle. Okay? All it does is connects the midpoint of that side to the other angle. Let's go from point A now. Mark the midpoint of side BC. Yeah, you have a question?
To be an angle bisector, it has to be a 90-degree angle at the...
No, to be an angle bisector, it just bisects the angle that it comes from.
So why'd you say 90 degrees?
Because the perpendicular bisector would bisect the other side. Folks. Okay? So I'm differentiating this from both the perpendicular bisector and the angle bisector. So from CB now, this midpoint, we'll mark these two segments as congruent. And we're going to connect this to point A. And you can kind of see now that our third median here coming from vertex B is going to intersect the other two. It kind of lines up rather well here. And depending on how accurate your drawing is, right? But here's the midpoint of side AC.
But we don't really know that.
Again, depends how accurate you are. But now connecting that to vertex B, there we have it.
What is that called?
Okay? That's called the centroid. The centroid. And we will call this point M.
It goes A, B, C.
We'll call this, yeah, point Z. So the reason why I chose A, B, C, and X, Y, Z was the beginning of the alphabet are the vertices of the triangle. These new points that we're creating on each side, I want the end of the alphabet, so it differentiates it from beginning to end. And then the point in the middle, again, it is a middle, right? That's why I called that M. It really doesn't matter what letters that you use, but that's why I chose what I did there. Yeah.
This is like a serious question.
Uh-huh.
Like, how do we know that's the middle?
So we're eyeballing this. If
Yeah.
you were, if you were actually,
Like, no, like seriously, though, like, how did we get that like middle part? Like, how did we get that?
you could measure it and come up with an accurate
No,
one there.
like, how did you get to that? No, I'm actually being so serious. Like, I'm confused how we got to M as the midpoint. Like, how we got to.
So we connected the three medians.
Why? Why did we put it in the middle? Oh, to the midpoint.
Now that M doesn't stand for midpoint, right? The M is the centroid. We already have point C. We don't want to use point C a second time. Again, if you want to, if that makes more sense to you, you go right ahead. But again, I chose ABC because they're all consecutive and the vertices of the triangle. X, Y, Z, the end of the alphabet, those points for the median. Okay. Vince likes Arlene Hale, please. Arlene.
I am still confused on how it's not an angle bisector.
Yeah, same.
It's not an angle bisector. Let's use an extreme example here. If we had a triangle that
Actually, could you use the same title?
hey
I
folks,
agree with that.
if I use the same triangle?
Yeah.
Okay, well, so if you just look at angle A, that's probably the one where it's most clear. You know, you can see, and I'm allowing you to use the eye test on this one here, but you can see that these two angles that AY makes are not congruent angles, right? So an angle bisector would give you congruent angles. I'll try to do the same triangle. So kind of that, and went up. Kylie, what is the issue today?
Alexis was asking me a question.
I don't think so.
What about any of the other people around you? Turn
We're on
around.
the A train.
I didn't hear that.
We need a better voice.
Yeah, why is Luigi?
Luigi on
So an angle bisector would come out of this angle bisecting it, and you can see that's not in the middle of that third side, right? In order to guarantee or go from that middle, that midpoint of the side, we have to sacrifice the fact that it's going to bisect the angle. Okay? An angle bisector and a median do different things. An angle bisector bisects the angle and hits the opposite side wherever it does. Okay? The median bisects the segment and hits the opposite angle wherever it does. Okay? So they're kind of opposites in a sense. But there you have it. Catherine.
Wait, so are all those lines in the middle of the triangle the medians?
All of them are medians, yes, because they all connect a midpoint of a side to the opposite angle. The point in red is the special point, the point of concurrency, because that's where the three medians intersect. Okay? So BZ, AY, CX, they're all medians because they all connect the midpoint to the opposite angle. But then that point in red, where those three intersect, the point of concurrency, that's the centroid, and that's got some special properties.
Okay.
Okay? Yeah,
Why is Luigi on the floor?
he fell. Anything else?
You should say, make us happy.
Got. All right. So what is special about the centroid? The centroid divides a median into a 2-to-1 ratio. The centroid divides a median into a 2-to-1 ratio. Right? Which means that one section is twice the length of the other section. And the part that's longer, the 2 of the ratio, 2-to-1, is going to be the part from the angle to the point. So here's your 2. From the point to the segment is your 1. Okay? Essentially, MB is twice as long as MZ. Okay? MB is twice as long as MZ. So, if I told you that MB, what's that? Because that's the property of what a centroid does. Knowing it's, how you tell it's a centroid?
How can you tell if that's longer than the other?
Well, again, the eye test kind of confirms that MB is longer than MZ, right? But the fact that this is a theorem, we know it to be true. Okay? Folks? Again, it's really tough to keep a rhythm going. I have to stop so often and tell people stop talking, turn around, etc. Okay? So if MB was 20, MZ would be 10. And from there, you can get the length of the whole median, BZ, which would be 30.
Easy.
Okay, I made them up. Okay?
He said all that.
I thought you did.
Yes.
Yeah, you are easy.
What a centroid does is it divides a median into a 2-to-1 ratio, which means that one part of the median is twice as long as the other part. Okay? The part from the angle to the centroid is the part that's longer. From the centroid to the midpoint of the opposite side, that's the shorter part. So, if you knew that MB was 20, and you put that 20 in a 2-to-1 ratio, then MZ would have to be 10. Okay, it's half the length of BM, right? Or BM is twice the length of ZM. And then total, if you've got one section that is 20, the other section that is 10, total, it gives you BZ, which is 30. Okay? Because like we talked about last year with ratios, 2 parts make a whole. Yes?
Is this kind of just like expression for like writing the lines out, but like if you're writing like MB or MZ, does it have to
No.
So you could have wrote C.
Yes. Okay. So let's say I tell you that CX. That looks like an angle. I'll make a better C. Let's say that CX is 51. What would CM and MX be?
Why is C uppercase? It's just, it's weird.
Now they're both uppercase.
Okay.
Is that for the triangle?
No, they should be. So if CX is 51, that's this entire thing here, right? The whole median. And knowing that point M is that splitting point where it goes in a 2-to-1 ratio, what would CM be and what would MX be? Ellen.
CN would be 34.
Okay?
And X would be 7.
All right. How'd you come up with that?
So I did 51 divided by 3 because there's 3 like total.
Excellent. Pause right there. She took the whole and she divided it by 3 because in a 2-to-1 ratio, how many parts are there? 3, right? So if you're taking 51, you're dividing it into 3 parts. CM gets 2 of those parts, and MX gets the other one.
Ah.
Okay, perfect, Ellen. Excellent.
So then you added 7.
Good stuff.
So we do kind of go back and practice our ratios a bit with these centroids. Any questions? Depends on how much you let me teach. Okay.
The bottom of the paper. Keep
What happened to Ms. Dawson up there?
In the figure P is the centroid of triangle XYZ. YP is 12, LX is 15, and LZ is 18. And from that information, you need to find LY, YN, LP, and XY. Now, a couple of things to remember. Okay, you are told that P is the centroid of the triangle. That's going to give you information about what the lengths of these medians are. Okay? Knowing what a median is and what it does, it's important to remember that a median bisects that opposite side. So that's going to help you get the side lengths that you need to find here. Okay, so go ahead, work with the person next to you only. I don't want you to get up and moving around. We'll pause the video and come back shortly.
I actually know these.
Okay, and we're back. Damien,
LY equals 15.
and how'd you come up with that?
Because XL equals 15, as we were given that.
Okay.
And I inferred that LY equals 15 as well.
Yes, and you don't need to infer this because you can confirm it. Because L being the midpoint of that side, if LX is 15, then LY would have to be 15 as well. Okay? So 15 is this one.
Can you run the table?
No. YN. Kylie.
It's 18.
And how to get that?
Because
Wait, which one are you talking about?
18. YN.
Catherine?
YP is 12, and so PN has to be half of 12, so it's 6, and 6 plus 12 is 8.
Okay, so we're given YP to be 12 here. And remembering what a centroid does, it divides into a 2-to-1 ratio. And this being the longer side, the angle to the point, that's going to be twice as long as PN, which is the centroid to the side. Okay? Which makes the total 18 for YN. Job well done. LP, Anthony.
Because of the 2-to-1 ratio, it's 6.
But how'd you get the numbers to begin with?
Because of the other side
Damien?
tells us it's 12, and then the whole thing equals 18.
Okay,
It's a 2-to-1 ratio.
so
So the other part is 6.
Noah,
Push it out.
Damien again. So LZ being 18, the whole thing, again, this divides into a 2-to-1 ratio, the longer side being 12 and the shorter side being 6. So LP being the shorter side, that is going to be 6 there. And lastly, XY, Ellen, it's 30.
XL, XL is 14, and then it's the midpoint, so the other one's 15.
Right, we already found LYB 15, you were given LX, and 15 and 15 would make a total length of 30. Folks. Last one. Joey, quiet please.
That's a fidget toy.
Damien, quiet please. That's the third time now. Okay. According to my calculations, a triangle YPM is congruent to triangle ZPM. Dost thou agree, and why? So YPM is here, okay? ZPM, I'll do that in blue, is there, okay? We already calculated ZP to be 12. And we calculated PY to be 12. So far, so good. What else do we need here, and how do we get it? Arlene, give me one of the other pieces.
Yes, because it bisects YZ.
Okay, stop right there. So we have another side here, right? We've got the two sides that were given to us that we solved for. We have a second side because we know that M is the midpoint. That'd be the definition of a median. Okay, and what's the third piece here? We have one side, we have a second side. Catherine, what's the third piece? They share a side, and we call that what? Reflexive properties. Okay, not linear pair, no. So, yes, they are congruent triangles, and we can use side, side, side to prove it. And there's the information that we found when we needed to make side, side, side happen. Damien.
Can we just eyeball it?
Nope.
Well, we
Not-
eyeballed it before.
Yes.
Class.
Yeah, I know.
Yeah,
but
you said
that
we
was
could eyeball
the
it.
I
beginning.
You
said-
eyeballed it.
I said in this case, in this
Okay,
instance.
well,
What about every other?
All right.
That's not fair to one inside.
You already talked. Life is not fair. What's that? My vision's not very good.
Is it like 15, 20?
It's not very good. Your homework's Monday.
Oh.
Jack, hey, stop asking you.
That's a cap.
Especially when I feel it's not
Maybe Damien should go over. Your legs.
On page 322.
That's all I heard about.
Alexis, I'm still recording. Folks, I'm still recording. Catherine, second warning for you. Yes. Probably a smart idea. 3 through 6 on page 322. Then let's do
Page 2.
33 to 35. And
You're making fun of me all the time.
Joey. Joey, I just got a bigger.
Anthony, I'm still recording. Stop talking. And page 325. Or sorry, on page 325, 3 through 5. Okay. I'm taking a class on how to edit videos. So for confidence, I can just splice off all the times I tell you to be quiet or face the front. Your parents walk in, they sit down, I just press play and I sit back
Maybe a little longer.
That'd be
and
way
wait.
too much effort you'd have to put in.
Nope, I'm taking a
We're
class.
And I really do my best.
Super easy.